This is Module 2, Upper Air Flight Equipment. There are a number of different types of radiosondes in use in Canada and around the world. All of them take the same kinds of measurements but use a number of different technologies. On Sable Island, Environment Canada currently uses the Vizsla RS-92 GPS sonde. A prominent feature is the sensor boom. At the top is the temperature sensor. The sensor below that is the relative humidity sensor that measures the moisture content of the atmosphere. Inside the radiosonde and not visible from this view is the pressure sensor used for measuring atmospheric pressure. The helical GPS antenna receives the GPS satellite signals and is used to compute the wind speed and direction. At the bottom is the radio antenna that is used to transmit data from the radiosonde back to the station. In the bottom of the sonde are two connectors under protective flaps. One connector is used for specialized sensors, for example, for measuring ozone or other atmospheric constituents. The test connector is used to connect the radiosonde to the GC25 test set for calibration and preparation for the flight. On the underside is the battery compartment. The battery connects to the radiosonde with a small plastic connector. The last component is the unwinder, a white plastic reel with 30 meters of string wound on it. When the balloon is released, the reel unwinds, so during the flight the sonde will be 30 meters below the balloon. This minimizes any error in the measurements caused by the balloon disturbing the air as it ascends. Here's the complete radiosonde. There are a few different varieties of balloons in use, but the Totex balloon is most commonly used on Sable Island. Balloons are differentiated by the actual weight of the balloon. There are sizes ranging from 3,000 gram balloons all the way down to 100 gram balloons, depending upon the intended use. We normally use an 800 gram balloon. The balloon film is made of natural rubber and is very fragile. The balloon deteriorates in bright sunlight, so should not be opened until just before use. It can be scratched by abrasion with rough surfaces, causing it to burst prematurely. It's important to clean off any surface the balloon will come in contact with. Even the skin oils from a bare hand can damage the film. The only part of the balloon that can be touched with bare hands is the neck, which is made of much thicker rubber. To inflate the balloon, we attach it to a filler stand in the balloon shed and then add lifting gas, either helium or hydrogen. Hydrogen is usually manufactured on site from the electrolysis of water. Helium is available in compressed gas cylinders, and sometimes hydrogen is in cylinders as well. The inflated balloon is about 1.5 meters in diameter. As it ascends, it will expand until it eventually bursts. At that point, it might be 8 meters across, with the rubber stretched so thin that the balloon is transparent. If the balloon ascends too quickly, the radiosonde may not accurately measure the conditions it's flying through. If the balloon ascends too slowly, the data may not be collected fast enough to meet time deadlines. The target ascent rate is 300 meters per minute, or about 1,000 feet per minute. The ground equipment is comprised of 7 components. The UPS, or uninterruptible power supply, provides backup power for the whole system. This will ensure continuous data if the power fails during the flight. The GC25 test set is used to test and calibrate the radiosonde before a flight. 2 antennas are located upstairs in the dome. The telemetry antenna retrieves the data sent back from the radiosonde. The GPS antenna records the local GPS coordinates. Together with the GPS coordinates recorded by the radiosonde, the sounding software computes the wind speed and direction. The receiver decodes the radio signals from the 2 antennas and provides numerical data for the computer software, which analyzes the data, prepares data messages for transmission, and archives the data. There is also a backup computer in case the primary computer fails. Finally, the data is transmitted to the Maritimes Weather Center through a data modem. This is the Digicora sounding software main display. We'll examine the features that are routinely used during flight operations. This is the view pane. It will display different windows depending on the task selected. This is the task control. Each icon leads to a different display inside the view pane. Right now, the sounding control is selected, and you can see that the flight is in progress. We can look at all the other views available in the task control. You've already seen the sounding control view. The radio control shows the signal strength and the sound frequency. The message control allows you to manually generate and view data messages. Raw data view shows a graph of the current flight data. Trajectory view shows the path of the sound over the Earth. And finally, satellite view shows the number of GPS satellites being received by both the sound and the local receiver. The hardware status pane shows the status of the system. The green OK indicator means the hardware is running. The yellow activity indicator means routine hardware activity. The red error indicator indicates a hardware error. A loose cable might mean that the green OK and red error are both lit at the same time. PTU status shows the quality of the telemetry signal and also shows the current values of pressure, temperature, and humidity. GPS status shows the number of satellites detected by the radio sound and the number of satellites detected by the local receiver. The calculation status shows whether the data is good quality and if the wind calculations are good or if there are problems with the satellite reception. EDT status shows the status of the flight. It most often shows the icons for normal operation and internal calculations. It can also show an icon when it's waiting for keyboard input. Check telemetry warns that there's a problem with the radio sound signal. And the last two status icons are sound coefficient error and terminal error. I don't know that we've ever seen either of these two icons in actual operation. Down at the bottom is the text pane. It's a scrolling window that allows you to examine the data in detail. There are 5 tabs you can select along the bottom. The System tab shows system messages such as the height the ascent reached, the reason for flight termination, the average ascent rate, etc. The Raw PTU tab shows the raw unprocessed pressure, temperature, and humidity data coming directly from the radio sound. The Raw GPS tab shows the raw unprocessed GPS data from the sound and the local GPS receiver. EDT shows edited data, where the software has corrected for garbled and missing data. The STD tab shows the data for standard levels in the atmosphere that are of significance to meteorologists, for example the 1000 hectopascal level or the 100 hectopascal level. The Digicora software automatically generates messages to enable the flight data to be transmitted to the mainland. Additional software collects the data messages after they're generated and then transmits those data messages to the Maritimes Weather Center. There's also software to display the current weather conditions from the Automatic Weather Observing System, or AWOS. On Sable Island, the upper air technicians are almost always working alone, and there's a staff working alone alarm. It's pre-programmed with standard times for balloon inflation and balloon release and other activities, and will sound an alarm if the technician hasn't safely returned to the office on time. Finally, we have a separate Anacom computer that shows live data received at the Maritimes Weather Center. This system is used to confirm that all upper air data messages are received properly and on time. This completes the description of upper air flight equipment.